Welcome to day 43 of our school year. Let's get that day filled in. Get our beginning fraction down. We have 180 total school days, and we are in day 43. Let's go ahead and find the factors of 43. Two factors we always know are 1 and the number itself. Using the commutative property of multiplication, I can do 43 times 1. Now we're going to check for other factors in an orderly fashion. So we're going to go after 1, we're going to do 2, we're going to use our divisibility rules. The rule for 2 is that it ends in an even number. It ends in an odd number, so 2 is not a factor. And if 2 is not a factor, no even number will work. 2 must work for any other even number to work. So we try the next odd number, which is 3. The rule for 3 is that we add the digits together. 4 plus 3 is 7. 7 is not a multiple of 3, so 3 is not a factor. We try 5. The rule for 5 is that it ends in a 0 or 5. It ends in a 3, so 5 is not a factor. We try 7. We just list the multiples of 7. 7, 14, 21, 28, 35, 42, 49. 43 is not in that list, so 7 is not a factor. We try 9. 9 has the same rule as 3. We add the digits together, we get 7. 7 is not a multiple of 9, so 9 is not a factor. We try 11. 11, 22, 33, 44. No, 11 is not a factor. Let's see if 43 may be prime. Let's check on our prime number sieve. Yes, 43 is prime. If it's prime, then it means it has exactly 2 factors, 1 and the number itself. That's it. So we need to figure out which one of these is our greatest common factor. So we'll see if 43 works. If it doesn't, then it's 1. So let's make our groups of 43. It does not matter what your groups look like, just as long as there's 43 in each group. And you keep your shaded separated from your unshaded. So 7 plus 30 is 37, plus 6 is 43. 4 plus 30 is 34. Plus 9 is 43. 1 plus 40 is 41, plus 2 is 43. I have 8 left over, so that means 43 is not a common factor. We can't have a remainder if it's a factor. So that means that 1 is our greatest common factor. Let's make our groups of 1. Done. How many total groups of 1 do we have? We have 180. How many are shaded in? 43. Okay, let's go ahead and now prove it with our algorithm. So we're dividing into groups of 1. Okay, 100 times 1 is 100. Number's the same, 0 is the game, more on top, no need to stop. 80 times 1 is 80. Number's the same, 0 is the game. 100 plus 80 is 180. So remainder is 0. We have our partial quotients there. Here, 40 times 1 is 40. More on top, no need to stop. Number's the same, 0 is the game. 3 times 1 is 3. Number's the same, 0 is the game. Add those partial quotients together. 40 plus 3 is 43. Now we're going to check. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Since our remainder is 0, and the identity property of addition says when you add 0, it stays the same, we don't need to add it. But what we get here is the identity property of multiplication that says when you multiply by 1, it stays the same. That's why that inverse works so well with the division. It stays the same. One group of 3 is 3, one group of 40 is 40, one group of 0 is 0, one group of 80 is 80, one group of 100 is 100. So 43 checks with 43, 180 checks with 180. So our numerator is definitely 43. Our denominator is definitely 180. All right, now it's time to fill in our data collection page. We're still in trimester 1, week 10. Today is 10/8/19, and our fraction for today is 43/180th. 43 is a prime number. It is not a factor of 180, so it means our greatest common factor was 1. Since we made groups of 1, you do not have to get your number line out. But I do want to show you it's right here, and that there are no lines lined up underneath, because this is our simplest form. It is our equivalent fraction in lowest terms. Okay, so go ahead and erase your worksheet, and thank you for joining me.